If you have these two angles here, these are called adjacent angles. And they have a specific classification. And so adjacent angles you cannot name with a single vertex. Okay, there's four different conditions that need to exist in order for two angles to be classified as adjacent angles. They have to be coplanar. They have to share a common vertex. They have to share a common side. And they have to have no other common interior points. Okay, so beside the shared side and shared vertex, there's no other common points. Okay, so if we look at these two angles, 1 and 2, okay, they're coplanar. They both exist in the flat surface up there on the wall. They share a common vertex right here. They share this common side as well. And when you look at the interiors, here's the interior of angle 1. Here's the interior of angle 2. There's no overlap, so it fits all four of these conditions. So angles 1 and 2 are considered adjacent angles. Okay, let's look at some cases of angles that do not meet all four of these criteria. Okay, so we'll take all three cases of angles that meet 3 of the 4 but miss 1, so they're not considered adjacent angles. Okay, let's say that you're missing condition number 4. Okay, so if I'll relabel this points A, B, and C here. Okay, and if I ask you to identify whether angle 1 and angle ABC are adjacent angles. Well, they are coplanar. They exist on that same flat surface plane. They share a common vertex, B. They share a common side, side AB, or BA, ray BA. But they do have they have common interior points. If we look, angle 1 is this gray shaded region. If we looked at angle ABC, ABC would have this whole region. Are there any overlapping points in the interiors? Yeah, so that one would not be meeting this fourth case. So this set, angles 1 and ABC, are not adjacent angles. All right, let's take a look at ones that are missing the sharing a common side. Okay. If I take and look at angles 3 and 4 here. These angles are coplanar. They exist on that flat surface plane on the wall. Okay, they share a common vertex right here. They have no common interior points. Here's the interior for angle 3. Here's the interior for angle 4. No overlap. However, they don't share a common side, so they are restricted here. So angles 3 and 4 are again not adjacent angles. Okay, let's look at two angles that don't have a common vertex but meet all the other criteria. So if I look at angles 5 and 6 here, they're coplanar. They share a common side right here. They have no common interior points. Here's angle 5's interior. Here's angle 6 interior. However, they don't share a common vertex. So just like those, angles 5 and 6 are not considered adjacent angles. The final case is an example of two angles that meet all the criteria except for the very first one. And so if I use a box to illustrate the three-dimensional aspect of these, and if I use this angle 7 and let's say this angle 8, okay, they have a common vertex right here. They share a common side right here. They have no common interior points. So here's the interior of 7, the interior of 8, no overlapping. However, they're not coplanar. 7 and 8 fall on completely different planes. And so when you look at that set as well, you're looking at another set that are not adjacent angles. Maddie?
Why are 5 and 6 coplanar? I don't really get that.
Means that they lie on the same flat. You can contain them within one single plane, and that they just don't share the same vertex. David?
How do I get the no common interior points? What does that mean?
That just means that I mean, and it's really for this set, like angles 1 and then the whole outer angle as well. That meets all the criteria except for no common interior points. It just means that one angle cannot be contained in an adjacent angle pair. One angle cannot be contained in the interior of the other angle. They each have their own unique interiors. So like if you had these two angles right here, angle 1 and 2, is there any overlap in their interiors? No. So that's kind of the definition of adjacent angles. I mean, and that's it. This is what they look like. Now, the problem comes when you look at this whole angle here, XYZ. Some people will think that if you took angle XYZ and you took angle 1, that those would be adjacent angles. But they're not, because all the interior points of angle 1 are also included within the interior points of this whole larger angle. So it doesn't meet that second